Faraday's Law 4. At right, the figure shows a metal wire bent into a U shape, along with a thick bar of metal that can slide left or right along the rails of the wire. We have a wire here that's bent into kind of a U shape, and then this thick bar of metal can slide along here, can slide to the left and right. Letter A. Draw symbols into the figure to show that the entire apparatus is located in a uniform magnetic field that's directed into the page. Into the page means we're going to use X's, and this whole thing, including the region outside of it, is in a uniform magnetic field that's directed into the page. If we wanted to label that, we might just call it B, something like that. Letter B. Use hatching, i.e. closely spaced parallel lines, but usually slanted, to indicate the region we would focus on if we are wanting to talk about EMFs, currents, induced in the system. The region that we would be dealing with would be this region right here, because whenever we're talking about induced EMFs and induced currents, aren't we talking about loops? And this is a loop right here. It's a complete loop. This portion over here on the left, that is not a part of the complete loop. This loop area, you see, we could change that, couldn't we? We said that this thick bit of metal can slide to the right, it can slide to the left. So the window here can change in size as we slide that thick bar of metal left or right. Will there be an EMF induced in the wire and the metal bar when the bar is, via some external means, made to slide either left or right? And that would be yes, because the flux through the loop will be changing. You recall that in simplest terms, magnetic flux is basically the magnetic field strength multiplied by an area, and sometimes we have to integrate things, but in simplest terms, that's what we're dealing with. And you can see when this metal bar slides, A is changing. Even though B is constant, A is changing. And so if the magnetic flux is changing, then yes, we will get an EMF induced. And will there be a current in this wire around that loop? Here again, the answer will be yes, because the loop is made of a conductor. We are told that it's a metal wire, and we're told that there's a bar of metal that can slide. So everything's a metal. So yes, there will be an induced current. If all of the stuff in the picture were non-metals, if we had this U-shaped thing and it was a non-metal, and this bar here, if it were a non-metal, there would still be an EMF that is induced if the flux is changing, but there wouldn't be a current. So you couldn't really do anything useful with it because an insulator would, of course, resist the flow of current.